Let's talk about the periodic motions. A periodic motion is one which repeats itself after a regular interval of time. The motion of moon around the earth, or the motion of earth around the sun, which completes one complete revolution in 365 days, that is a periodic motion. And when we talk of period, the 365 days is the period of that periodic motion of the earth. We have got oscillatory and simple harmonic motions. When we talk of oscillatory and simple harmonic motions, both are periodic. That means they repeat themselves after a fixed interval of time. That fixed interval of time is called as the time period. When we talk of oscillatory motion, an oscillatory motion is a periodic motion in which there is to and fro between two extreme positions. So oscillatory motion is a bounded motion between two boundaries. Those two boundaries are called as extreme positions of that motion. When we talk of simple harmonic motions, in simple harmonic motion, there is a restoring force. That restoring force is always directed towards the mean position. To represent the periodic motions, we take help of the sine and cosine functions of trigonometry. That sine and cosine functions are periodic with a period of 2 pi. That is, after an angle of 360 degrees, the cos function and the sine function repeats itself. If we take a look at the sine function, the sine curve looks like this. At angle 0, its value is 0. At angle 90, its value is 1. At angle pi, its value is 0. At angle 270, its value is -1. At angle 360, its value is equal to 0. That means it repeats itself. After another cycle, it looks like this. Same. After one complete cycle, same cycle is repeated. That means its value, the value of sine, lies between -1 to 0 to 1. And it repeats its values after an angle of 2 pi or after an angle of 360. That when we talk of periodic functions in physics, to represent them, we can take help of this sine function. We can take help of the cos function also. The difference between the cos and the sine function is that when we take look at the cosine curve, that cosine curve starts from a higher value, that is 1, then 0, then -1, then 0, and then 1. So it also repeats itself after a period of 2 pi, that is 360. Now, difference between sine and cos is that the sine wave starts from the value of 0 and the cos wave starts from the value of 1. In oscillatory motion, its physical significance is that when we represent a periodic motion in terms of a sine wave, that means its motion starts from the mean position, that is 0 displacement. When we represent a periodic motion in terms of a cos wave, that means its motion starts from the extreme position. That means it has already traversed a displacement of y is equal to 1. That means its motion is starting from the extreme position. So when we talk of periodic motions in physics, we can represent them in two mathematical functions or two trigonometric functions, that is sine and cos, with the difference of when it is starting from the mean position, we can take the help of sine curve. When it is starting from the extreme position, we will take the help of cosine curve. Let us take a look at the velocity and the acceleration calculations in terms of periodic motion. Let the displacement of the periodic motion be given by y, and y is equal to a sine of omega t. While a is the amplitude, sine omega t means it is a periodic function, and that too is starting from the mean position. If it had been cos, so that will also represent a periodic motion, but starting from the extreme position. Easy. Now, when we talk of the velocity, from the Newtonian mechanics, we know that velocity is differentiation of displacement. So v is equal to dy by dt. That means v is equal to d by dt of a sine omega t. Amplitude being constant, it is taken out of the differential sign. That means a d by dt of sine of omega t. Now, differentiation of sine is cos, so a cos of omega t, and internal differentiation of omega t with respect to t, that is omega. That means the velocity in terms of periodic motion, that is equal to omega a cos of omega t. Its physical significance is that when y is equal to a sine omega t, velocity is equal to a cos of omega t. Talking about the physical significance of y is equal to a sine of omega t, and as already derived, v is equal to a omega cos of omega t. We know that here it is the mean position, so the displacement is 0. Here it is extreme position, so the displacement is y. Here also displacement is equal to minus y. Now, when we talk of displacement here, displacement is equal to 0. Displacement is equal to 0 because omega t is equal to 0 and sine 0 is equal to 0. Here, when we talk of the angle, here angle or theta is equal to omega t, that is equal to 0. So displacement is equal to a sine of 0, that is equal to 0. And is the mean position, it is displacement is equal to 0. Now when we talk of the velocity, when we talk of velocity here, so v is equal to a omega cos of omega t, that is 0. Cos of 0 is equal to 1, that means velocity is equal to a omega. So here the displacement is equal to 0, but the velocity has got the value of a omega. That means it is leaving in this direction. So the velocity at the mean position is maximum, and that maximum value is equal to a omega. Now when it is leaving in this direction at extreme position, angle is equal to 90 degrees. So y is equal to a sine of 90, that is equal to a. So the maximum displacement is equal to the amplitude here, and the extreme position, the displacement is maximum. When we talk about the velocity, velocity is equal to a omega cos of 90. That means cos 90 is equal to 0. So velocity is equal to 0. That is why it is not going beyond this extreme position. At this extreme position, the restoring force is maximum, which we will see in the acceleration. The restoring force is maximum, and this comes towards its mean position. Why does not it go beyond this extreme position? Because the velocity here is equal to 0. So it should be clear that at extreme positions the displacement is maximum and the velocity is 0. At mean position the displacement is 0, but the velocity is maximum. That is why it overshoots its mean position and goes to the extreme ones. Now talking of the acceleration, we know that y is equal to a sine of omega t. Let the motion start from the mean position. Now velocity will be equal to the single differentiation of displacement with respect to time, that already discussed, a omega cos of omega t. And we know from the study of mechanics that acceleration is the differential of the velocity. So a is equal to dv divided by dt. That means a omega being constant comes out, so d by dt of cos omega t. And we know that differentiation of cos is equal to minus sine omega t, and internal differentiation of omega t is equal to omega. That means a is equal to minus a omega square sine of omega t. Or when we see a sine omega t, that a sine omega t is equal to y, we can say that a is equal to minus omega square y. The physical significance of this negative sign is that, as already discussed, acceleration is always towards the mean position. That means when it is leaving from the mean position, then acceleration is always directed towards the mean position. That is why at extreme position, the value of the acceleration will be maximum towards the mean position. That is why from the extreme position, it is coming towards the mean position. It is its physical significance. Now, looking at the values of the acceleration at mean and the extreme position, at mean position, acceleration is equal to minus omega square, y is equal to 0. That is, acceleration is equal to 0. And at extreme position, that is equal to minus omega square y. At extreme position, y is equal to a. So acceleration at extreme position is equal to minus omega square a. The physical significance is that here the velocity is maximum. Here the velocity is maximum. So the acceleration is equal to 0 because acceleration is the rate of change of velocity. When we talk of maxima and minimas, change of maxima and minima are always equal to 0. Here the velocity has got the maximum value, that means there is no change in velocity at mean position. That means the acceleration is equal to 0. Here the velocity is equal to 0. But there is change in velocity. There is maximum change in velocity because the velocity is in this direction and the acceleration is in this direction. As there is change in velocity at the extreme position, so at the extreme position, the acceleration is maximum. Now, this acceleration into the mass of the body, this acceleration into the mass of the body is called as the restoring force, and the restoring force is always directed towards the mean position, as I talked about the oscillatory and simple harmonic motion. And oscillatory and simple harmonic motions are those motions in which there is a force that is always directed towards the mean position. That means that force brings it back towards the mean position, and that force is called as restoring force. Thank you.